Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel A-Level paper from 2018 and this is paper 1 and we're covering all the questions, so if you find this helpful please consider subscribing to our channel. So we're on question 10 and this is actually a differential equation. So we've got the height of a roller coaster, the height of in h meters of a passenger on a roller coaster is modelled by this differential equation where we've got the differential of the height with respect to the time is equal to h cos 0.25t over 40. And what we've got to do is, given that the height of the passenger is 5 meters from the ground when the ride starts, we've got to first of all show that h is equal to 5e to the 0.1 sine 0.25t. So what we have to do is we go to our differential equation here. I'm just going to write this out again. So dh dt equals h cos 0.25 t all over 40. And we can actually treat the dh dt as though it's just a fraction. So with a fraction, we could multiply both sides by the denominator of the fraction, and it would cancel on one side and appear on the right-hand side. So if we do that, then what we'd end up with is that dh, multiplying both sides by dt, is actually equal to h cos 0.25 t over 40. And the dt will end up here. And in fact, what I'm also going to do is anything with h in it, I'm going to try and get over to the left-hand side with the dh. And anything with a t in it, I'm going to leave on the right-hand side. So the h here is in the numerator, so multiplying the cos. So if I divide by the h, then what I'll end up with is 1 over h dh, so h will go into the denominator, and actually I can then put an integral sign on there, and I do the same on this side. Then I can say that cos 0.25 t dt over 40 is what I'm left with, and I can also put an integral on this side. So what I've got then is an integration problem. So all I need to do is integrate both sides of this. So the left-hand side, if I've got 1 over the thing that I'm integrating, then that actually turns into natural log. So that'll turn into a natural log of h. And strictly plus a constant as well. It's not a definite integral, but because I'm going to add a constant on the right-hand side, I don't really need to put constant on both sides. So if I try and now integrate this, what I'm going to end up with is the cos of something will end up as sine of 0.25 t, but because it's a linear function of t in the brackets, it's 0.25 t, I can take the differential of the 0.25 t, which if I differentiated that with respect to t would just be 0.25, and this is, I can only do this if it's linear, so 0.25 t is linear, and I divide by the result there. So I've already got 40 in the denominator, and I've got to divide by the 0.25 is to multiply the denominator by 0.25. And now what I am going to do is add a constant there. So you can see that if I'd added a constant here on this left-hand side as well, and I'll give it a different letter, I could really just take it away from the left-hand side, and I'd take it away from the right-hand side as well, and I'd be left with a constant anyway. So that's why I only need to write it on one side. So I've got the log h, and I'm just going to tidy up this a little bit. So the 40 times the 0.25 is 10. And if I want to put that in the numerator, if I'm dividing by 10, then 1 over 10 is equal to 0.1. So I'm just going to call that 0.1 sine 0.25t plus c. So we're getting to where we need to be for this. You can see we want it in this form where we've got h here is equal to 5 times e to this power. So what we need to do then is get rid of the natural log here. And the way we can deal with that is if we took both sides to made them both powers of e. So just doing the same thing to both sides as we can do with equations. Then the e and the log will cancel, just to give me h on that side. And I'm ending up with e to this power. Now, if we look at the rules for when we're adding a power, so it's a bit like having x to the 1 plus 2, for example. We know that would be 3, but that would be x to the 1 times x to the 2. So we add the powers when we multiply. I'm just going to rub that out just to make some space. So here, what I could do is work in reverse. So what I can do is I can take the c there, the plus c, and make that e to the power c to multiply e to the 0.1 sine 0.25 t. And because e to the c, e to a constant is another constant, so I'm just going to let k equal e to the power c. So that's going to simplify then to just being constant k times e to the 0.1, all this lot, sine 0.25 t. And that's looking very like what we're looking for, h equals 5 e to 0.1 sine 0.25 t. We just need to get this 5. And the way we're going to do that is it says given that the passenger is 5 meters above the ground at the start of the ride, well, that would be when t is equal to 0. So if we replace t equals 0, so what we've got is we've got that h equals 5 when t equals 0. So if we substitute this in, we'll get that 5 equals k, and then e to the 0.1, all this lot again. And then just replacing the t by 0. And now, sine of 0.25 times 0, this bit here is going to equal 0. So sine of 0 is actually 0. Think about a sine graph. So this really simplifies to 5 times k e to the power 0, because the power of the e is 0. And e to the power 0 is equal to 1. So that simplifies again to 5 equals k times 1, which means that k is equal to 5. So now we've found what k is, we can just replace it in our equation for h that we discovered from solving the differential equation. So we end up with that h is equal to 5e 0.1 sine 0.25 t as required. So that's part A done, and part B, we've got to state the maximum height of the passenger above ground. So this is only a 1 mark part of the question. So going right back down to here again. So the maximum height, well, that must be, part B this is, that must be when sine is maximum, because we've got e to a power, and so if we make the power of e as big as it can be, then that will give us the maximum height. So that's when sine is maximum, and the maximum value for sine, so I'll call it sine max, equals 1. So that would mean that the maximum height, h max, let's call it, would be e, 5 times e, and then 0.1 times 1 for this, so just 0.1. And this is just a case of substituting into the, or put it into the calculator. So I'm going to do that. So we've got 5 times, and then to get the e, I've got to get shift, and it's just there in orange, so e, and then to the power 0.1. So there it is. And if I do that to 3 significant figures, then that will be 5.53, 3 significant figures. 5.53 to 3 significant figures. Okay, so then the final part was, it says the passenger reaches maximum height t, the maximum height for the second time, t seconds after the start of the ride. So we've got to find the height, the value of t when the height is at its maximum for the second time. So part C is time for second maximum. And bearing in mind that we've got again our equation, all this lot, 5e 0.1 of this. Well, the second maximum value for this will be when sine is maximum. So it'll occur when sine is maximum. And so since the maximum value, as we said before, is 1, we're actually looking for sine of 0.25t has got to equal 1, because that's the maximum value that it can be. And so we're looking for solutions for when 0.25t then would equal sine minus 1 of 1. And it's important to realise, by the way, we must be in radians for this. So when you're doing calculus, then you're never working in degrees, you're always working in radians. So consider a sine graph. What it would look like would be, as we're very familiar with, would be something like this. So it continues on. And so the first time that sine is maximum is at this point, which when we're working in degrees, we know that's 90 degrees. Well, in radians, that's pi by 2. And if we want to just check that out, we could obviously make sure we're in radians as well. So if I go onto the menu, not that one, if I go shift setup actually, angle unit, and then I want to be in radians, so I'm going to press 2. So if I go shift sine of 1, then I'll get pi by 2. So that's my first value, that's the maximum, but we're interested in this second one here. And because the graph repeats over 2 pi, then if I add 2 pi onto that, actually that would end up being 5 pi over 2, that point. And that's the point that we're interested in. So we're interested in 0.25 t is equal to 5 pi over 2. And so we're just going to divide by 0.25 there. So t is equal to 5 pi over 2 times 0.25. Actually, dividing by 0.25 is the same as multiplying by 4. So I'm just going to call that 20 pi over 2, multiplying the 5 by 4, and that's equal to 10 pi. And we don't really even need a calculator for that, because we know that that's going to be 10 times 3.142. So just move the decimal point one place, and that's going to give me the 3 significant figures, 31.4. And this is in, let's check this, I'm sure it's in seconds that it were the units. So t is the time in seconds. So we found that it's 31.4 seconds. Actually, it was big T that it was given us. So there we go. So I hope that's been helpful to you. If it has, please like our channel, give our video a thumbs up, and also consider subscribing to our channel. And for more help, if you want online tuition, I do actually do online tuition, and you can email me at admin@bestmathstutors.co.uk. Thanks for watching.